Hello everyone. Let us see how to make use of user-defined exceptions in C++. Just to have a quick recap, we know that exceptions are runtime anomalies and exception handling is way of handling exception such that program do not terminate abnormally. Three keywords are used. Try, used to represent the block of code that can possibly throw an exception. Catch represents a block of code that is executed when particular exception is thrown. Note that multiple catch blocks are possible for a single try block, and depending upon the data type of thrown argument, matching catch block will be executed. The keyword throw is used to generate and throw an exception. Even that is also used in declaration of function to specify list of exceptions thrown by that function. The syntax is very simple. It starts with try block, which contains statements, maybe throw statement directly, which will throw the exception. It could be a call to function, and that function will throw an exception. Then we have catch blocks. A generic catch block, that is catch dot dot dot, will be at the end, and any other catch blocks are there, they will be matched by its type. Till now we have seen the primitive data types as an exception type. Now today we want to see the user defined exception classes. C++ library provides few standard exceptions. These exceptions are defined in the file header file exception, and that is available in the standard namespace. So let us see the hierarchy of C++ exceptions. The base class for all the exception is the exception, which is parent class of all standard C++ exceptions. Then there is bad alloc. This exception can be thrown by new operator used for memory allocation. Bad cast exception can be thrown by dynamic cast whenever there is problem between type casting. Bad type ID exception can be thrown by type ID. Bad exception, this is useful device to handle unexpected exceptions in C++ program. In addition to these four, there is runtime error and also logic failure. The overflow error is mathematical overflow. Next, the range error is occurred when you try to store a value which is out of range, typically with enumerators. Underflow error, this is thrown if a mathematical underflow occurs. Under logic error, there is first one domain error. This is an exception thrown when mathematically invalid domain is used. Invalid argument is thrown due to invalid argument pass. The length error is typically when we pass a very long string, and out of range, this exception can be thrown like at methods for vector, bit set, operator. This is typically related with the indices. When you want to create your own classes to handle the exceptions. This is very simple. This can be done by inheriting from and overriding the functionality of this exception class. Note that this exception class is available in the header file exception and it is part of standard namespace. One of the most important thing is exception class has virtual member function called as what that returns a null terminated character sequence that is nothing but character star pointer, and that can be overridden in derived classes to contain description of the exception. For example, you see it here, I am creating a new class called as my exception. So here name of my class is my exception, and this is public derivation of exception class. The signature of what method is virtual const character star what. There is no argument. This is constant method, so this is not supposed to modify any member. And after that empty throw is there. Meaning of this is this what method do not throw any exception. Now this returns some character star. Note that it should be const character star. I repeat, this virtual keyword defines what as a virtual function. Const character star is return type. What and empty parenthesis is name of the function. Const means this is constant method which do not modify members, and throw is used to specify the exception list. Here it is empty, that means this do not throw any exception. Now how to use it? For example, I'm writing try block here and I'm directly throwing the exception. So here I use throw my exception and empty parenthesis. Note that this will create object on the fly by calling the constructor, and then we can write the catch block. The important thing here is the type of exception I am throwing is my exception, and the type I am using in catch block is exception. That is possible because exception is base class for my exception, and because we have virtual method what, even though data type of e, which is the parameter for catch block, so data type of this e is exception, but actual object stored in it is my exception. And because it is a virtual method, depending on what are the contents of e, not depending on what is the type of e, the what method will be called. Definitely this will display my exception happened. One more important thing is the exception class has the virtual destructor also. For any reason in your exception class, if you are making use of your own constructor, then you must write destructor also. Otherwise compiler will report the error. Now in the given example, I have not used any constructor, so I have not defined the destructor. Let us have a look at one example. Now this is stack.h file. So basically I am writing class stack in header file. Stack.h is also okay, but generally stack.h or .h refers to C header file and .hh refers to C++ header file. So I just use stack.hh. What I'm doing in this is I'm writing a class for stack. Three members I use. One is the capacity, which is the capacity of the stack. Next one is top of the stack, which is the entry and exit point, and I use one integer pointer to implement dynamic array. In the constructor, I just took capacity as an parameter. This is the capacity where maximum number of elements will be stored onto the stack. This will be given by the user and assigned to the data member underscore capacity. I initialize top with -1 and I use new operator to allocate memory to my integer pointer underscore data. This is just a message which will display like stack object with capacity, whatever capacity mentioned by the user is created. Next, this one is the destructor where I use delete operator to release the memory allocated by new operator. I initialize data to null because whatever memory allocated, that was just released, and I'm displaying just message that stack object is destroyed. Now after constructor and destructor, I want to define two methods. Push, that is used to store the elements onto the stack, and pop, used to remove the element from the stack. Now in push method, whatever element we want to push is taken as a parameter. Very simple algorithm. The top is incremented and new item is stored at the location data of top. That's it. So very simple thing. Note that we are not using any error handling here. Typically stack overflow. Now in the pop operation, there is no parameter. The element or item we want to pop is from the top of the stack. So item will hold the value data of top, and now top will be decremented. Whatever the item we took from top of the stack will be returned back. So this is very simple class used to implement stack. Again, note that push beyond the capacity and pop when stack is empty. These two errors are not handled. Now moving to the main. This is the driver program used to check our stack. So I just included the header file stack.hh so that I can use newly created class. Few variables I declared here, where capacity denotes number of elements you want to store on to the stack. Npush is number of push operations you want to perform. Npop is number of pop operations you want to perform. So these values are taken as an input using cout and cin. Then on line number 13, you see my stack object with the required capacity will be created. And then push operations. We took npush as an input. So if user specify three elements will be pushed onto the stack. I am just making use of the index plus 1 as an item. This statement just displays trying to push whatever the item you want to push. Then actually method of my object will be called. So my stack.push, this will be pushed, and if everything is okay, will display just okay. That means element successfully pushed onto the stack. Exactly same manner, we have taken npop as an input, that is number of pop operations. Will display trying to pop the element. The item will be popped, and then whatever the item pop will just display. At the end of the program, statement will be displayed. This is the driver program. Note that three inputs are required for this: capacity, number of push operations, number of pop operations, and all the items we are dealing are integer. Now let us go to the terminal, compile this program. So clang plus plus is the compiler and name of the main file is main.cc, sorry, cpp. So there are no errors. Let us execute it. It is asking for the capacity, number of push operations and number of pop operations. So let me give capacity of my stack is 5, number of push, say for example 3, and number of pop is 2. Let us have a look at the output. Constructor displays this message, stack object with capacity 5 is created. Now I mentioned 3 push operations. So trying to push 1 is okay, trying to push 2 is also okay, trying to push 3 is also okay. Then after 3 successful push operations, number of pop operations I mentioned is 2. So first pop is, it pop item 3 because that was last push. Then next pop is item 2, then end of the program, and then stack object destroyed. So this is successful execution. Now let us try to create errors there. So let me execute this code one more time with capacity say 3, just single push and maybe 3 pop operations. This is definitely wrong because number of elements we are pushing is 1 and number of elements we are trying to pop is 3. Now you can see it here, stack with capacity 3 is created, element 1 is pushed, okay. Now pop operation, it initially popped 1, that was the last push, this is also fine, but if you see this output, this is definitely wrong because we have just pushed one element that we pop. So now stack is empty there, and if you try to pop it, this is definitely underflow error that we want to handle. In the similar way, if my capacity is 3 and if I try 4 push operations, that should also result in overflow error. Let us see how to handle these errors with user defined exceptions. So now we'll go back to the editor. This is my stack header file. Step number 1 is to include the exception header file. So hash include exception. This is the step number 1. Let us try to write class about this class stack. So class stack exception. This is the new class I want to create. This will inherit the exception functionalities. So just we need to override the what method, and it is virtual character star, that is the return type. What, this is the constant method which throws nothing. And just remember that it returns character star. So what I'll do is I'll just return stack exception. This is how we can create a user-defined class to handle the exceptions. Now let us try to make use of it. use this class in push and pop. So in push method, we just need to check the value of top. So the condition for overflow is if top equals capacity minus 1, sorry, name of the member is underscore capacity minus 1, then throw stack exception. This will call the constructor and it will throw. Similarly, in the pop operation, let us check whether the stack is empty or not. So if top equals minus 1, then we want to throw exception. So throw stack exception. Let us save this code. Now go to the main program and now make use of try block. So what I'll do is I'll put the body of for loop in try. So try to push the element and now catch exception E, and to get the description of the exception we'll invoke the method E dot what, and L is used to move to the new line. Similarly, I'll do it for pop operations. So try to pop the elements, catch the exception E, and display the description. So see out E dot what. So we tried to push the element. If everything is okay, it will work fine. If it throws any exception, that we are handling here. So now let us save this, move to the terminal. I'll compile the program again. Main.cpp. Okay, there is one warning, but we can ignore that. Now try to execute it with the 5, 3 push and 2 pop. This is fine. Try with capacity is 3, 1 push and say 3 pop operations. Remember, you'll get here stack exception. Even you try, if capacity is 2 and if you try to push 3 elements and pop 1, 2 are pushed and there is a stack exception for. So this is the exception occurred here. So this is the way. If you need to specify the specific error, for example, overflow for push and underflow for pop, because here I just mentioned stack exception for push and stack exception for pop. We can implement that with data members. So let us go back to our exception class. Now what I'll do is I'll take one data member of type string, say string description. Let me write constructor for it. So stack exception string, let me call it as a error message or just error message, which I want to initialize. So description is equal to whatever the error message we send as a parameter. And here we want to return the description. Here the problem is the data type of description is string and return type of this what function is character star. So we need to convert string to character star, and for that there is a function called as c underscore str. So dsc dot c underscore str. This is used to convert string to character star. Now, as I mentioned in the presentation, if you write your own constructor, then you must write destructor also. So we need to add the destructor. So let us write destructor here. Name of destructor is tilde followed by name of the class. And let me have empty body. I don't want to do anything in this. And this virtual destructor throws nothing. Let me add name of exception here also. So it is stack exception and whatever the exception given by the error message. Save it. So save this, go to the terminal, compile the program again. Sorry, we forget to use the parameterized constructor here. So go to the main.cpp. In stack class, whenever you are throwing the exception, so this is push operation. Let us throw the overflow, and in pop underflow. So save it, move to the terminal, compile the program, and now again execute it. Say for example, capacity is 3. Try to push 4 and also try to pop 4 elements. Now here you'll get that first 3 items are pushed successfully. Then while pushing 4th element, there is an overflow method. 3 elements are popped successfully. Here stack becomes empty, and when you try to pop one more element, it results in underflow. So thank you.